thank you for this opportunity for me to present in this conference. And my name is Pei-Hsuan. I'm from Taipei, Taiwan, and this is the topic that I'm going to present. So the topic is a synthesized Mandarin speech dataset for stuttering detections and classification. We would like to do this study is because we found that the stuttering at the early age is a common speech disorder, and that can be treated at the early age. But we also found that when we wanted to treat those younger kids, and there is less existing public stuttering data set, especially for Mandarin. The Chinese people and also the people in Taiwan, we all speak Mandarin. So the data set is too small, and they often lack sufficient annotation. So that's why we would like to establish a database. And then also we wanted to test if the model can classify the stuttering patterns. And so we will see that there are different types of the stuttering events, but they are in different scenarios, so they were annotated differently. It's because they have different linguistic complexity, different languages, not necessary. In the data set so far, we can found that's not speaking the Mandarin. Even there is some data set that's using Mandarin, but it's still not much. And then if there are stuttering data sets, they are in different languages, and then they have different linguistic complexity. And we also found that when the researchers, they are establishing a model, a classifications model, and they are using they have different purposes, different intention, and they also have different annotation strategies. And so we decided that we definitely need to establish a stuttering data set for Mandarin speakers, and also train the model and to make sure that we will be able to classify the stuttering pattern. So this is our research purpose, to develop a classifier with the capability to detect stuttering events automatically, so that we could, in one way, we can improve the speech recognition systems, and in the other way that we can help the speech pathologists to track an individual fluency over time. So we propose the following research methods. Since there are different types of the stuttering type, so we will only focusing on the ones to most of the doctors, and also in the literature that we see that the stuttering types are very common. So there are 3 types of stuttering events. Of course, we will also have the other type that is a fluent speech, so that can do the comparison. So 3 types of stuttering events. One is the block. And the block means that someone that when they are talking, they will silent, they will pause, but the time that when they pause will be very different. But, that is quite normal, because we will pause because we can change our emotion, or we can change our tone, and then to express different thoughts, or we could strengthen our arguments. But kind of a block in the stuttering pattern is that the silence may pause with a different variation of the time. So that's why we wanted to emphasize in our data set, is to insert some silent pause, and then to make sure that there are presenting various pause durations. The second type would be the prolongation, means that the person, when they are pronouncing a sound or a syllable, and they will extend that sound or syllable for a few milliseconds without knowing. If we wanted to emphasize our data set to present that pattern, then we have to elongate that kind of a sound, so that we could imitate the persons who are trying to be like stuttering speakers. The third one is the repetition. Sometimes we are so nervous, so we will repeat some words or syllable. But for the stuttering speakers, unintentionally repeating the same last word. So we also need to repeat using this kind of the pattern in our audio recording. Of course, we have to find a data set, and then we can processing all different kinds of the stuttering events. And then we manually review, and to make sure that the synthesized stuttering can be aligned with each one of the category, the block, the prolongation, and the repetitions. And so finally, we create a data set, and then the data set's already labeled, so that we could guarantee that we know the ground truth. we have that information so that we can continue to train the model. We didn't include other kinds of the stuttering event because they are not the clinical salient stuttering type, but other type we will just consolidate it into like repetition or prolongation or the block. And so you can see that on the top is the original waveform used for block. At the bottom, you can see that we inserted the block into the original waveform. Then we will see that it has been a longer block, but that's not much. And then the upper part is also the original waveform used for the prolongation editing, syllable or sound like this from the top to the bottom. So we prolongate it a little bit longer. And the other type is the repetition. So original one is on the top, and then the bottom one is the editing waveform. Original is this part, and then we repeat it 2 more. And that will also represent the people whenever they are speaking with some stuttering events that will be easily to detect. Where we get the data source, that should be our foundation. And so that we can create those 3 different kinds of the stuttering events, primarily are from the CA Bank Mandarin Taiwan corpus, because it has a lot of different kinds of the natural people and people interactions. It's presenting the real world speech patterns. And the most important thing is that the audio quality is pretty high. But the thing is that they didn't provide a lot of documentations and to tell us how they processing those or pre-processing those audio. And this is open source, so you can request it. And the other one is also an open source. You can see this is from our university. We have a language center, and they create a corpus. They're providing a very detailed metadata. And however, we found that the environmental noise must be removed before we use it. This is one is from also in Taiwan. It's from Silicon Academic. But the thing is that they require a lot of processes to do the licensing. And then there's also some documentation allowed us to read, but we need to still processing a lot of works. So we're using the first 2 to be our foundation and then to editing the stuttering event for free type. And so these are our synthesis procedures. And then we have we know how to do this is because we review a literature from the most famous SEP 28,000 or 28K dataset. And there is also an article, research articles, and detail how to do this. And then we also get some idea that how can we segment or to select our audio clips and then to do the editing. And we have 360 audio clips when we selected from the original, and then we extracted them and then editing them using Audacity. Usually it's just 60 seconds of the audio clips, and then so we have to randomly to put all different kinds of the stuttering events within 60 seconds of the audio clips. We also need to carefully segment them so that whenever they are speaking, you will feel like this is the person who are stuttering, but he or she is talking to someone else. And so this is make the stuttering, the whole conversation sounds like very natural conversation, like you are converse with this person who are stuttering. And then we review and we listen to each one of the audio clips. So for 364, actually after that, 364 in total audio clips that we will be able to produce the stuttering events. Compare with the currently literature presenting this data, and we will have 4.62 events per minute, means within 60 minutes. And you could also see that we distributed the stuttering type into 3 plus fluent, so that's none. So about 1/3, 27% of the audio clips, they have a stuttering, do not have any stuttering type. But the others, you could see block 16%, prolongation 30%, and repetition 27%. This is by randomly editing the audio clips and then have that kind of distribution. Well, we also wanted to address that this data set can be requested. You are interested to analyzing further with those synthesized Mandarin speech data sets, and you are very welcome to request it. But you could see that these are artificial, and because there's no diversity in the pitch. And you could also see that the two different kinds of the sources that we get, but they do not consider other accents. The people in the northern part of Taiwan, southern part of Taiwan, or middle part, or the east part of Taiwan, we have different accents when we speak Mandarin. And the mainland China, when they speak Mandarin, they also have different accents. We also do not consider the age group when we speak, because people having different age when they are speaking with the stuttering events, that will be quite different, especially elders. And that will also relate to the people who have the Parkinson's disease or they have a dementia. And we do not also consider the genders. We only pick the audio click and did not differentiate whether they are biological genders in female or male. And finally, we are going to train our classifier, since that we have those stuttering events and in the data set. So we do prepare our data, and then we have to carefully to select the model. And I would like to show you the model that we tested. We are using the RNN, FluentNET, and the CNN. And we also have the YAMNET with the CNN. And so these 4 different kinds of the models that we use is because they are presented in the current literature already. And so we also wanted to use our prepared data sets and to test the model which has been tested in the current literature and to compare with others. And we do the feature extraction by following the literature suggestions. And then we also do the model training. All of these procedures are standardized, and we are just following the literature that has been used to develop different models. And finally, we evaluating the results. And then, so this is the experimental results. As you can see that the best one would be the FluentNET. However, the worst one is the RNN. You can see that the apple will be only 13 apples. That's going to our conclusion. We try to provide this data set so that we could open much more opportunity for other researchers who are really interested in this, studying this related topic. And we will really want to see that the FluentNET performance, if we could have our data set to be more authentic. And we will also want to know whether the way that how we train the model differently, that will perform the models better. And we will also see that the other model didn't really perform well. That's because of the model architectures, the back-end algorithms. But we could also try other ways so that we could have the model perform better. And so we will see that if we can through some of the administrative process by collaborating with the hospitals, and so we could get the data, authentic data, and we could also improve the model generalizabilities, because this has become a real data sets, and increase the reliability for our model training. It will be very robust if we can get the authentic data, and then it can be used in the clinical scenario. And we will see that if we could get a wider range of the speaker demographics, but it is really difficult because we don't expect there will be a lot of people having stuttering or speaking disorder. But we will really want to utilize this data set in a broader way in the real world Mandarin population. And thank you very much for your listening.